All right, we're going to continue with the quadratic functions. We're going to look at the table of values where we're going to use the table of values to graph. That's a very first basic thing that we need to know, and also we need to look at the domain and range of the quadratic function. All right, so we have this equation or the function y equal to 2x squared minus 4x minus 11. I changed the f of x to y, but I want to make sure that you realize that they're both the same. So I could have put in here f of x. Okay, same thing. And table of values, I said reasonable values of x. So I started with minus 3 for x and minus 2, minus 1, 0, 1, 2, 3, 4, 5. And these are all random values of x I chose because it's reasonable, I'm thinking. And you can choose any other ones you wish. And then what we want to do, we want to grab each of these ones, plug it back into the equation, do the math, and come up with the value for y. So for example, when I plug in minus 3 in there and did the math, I got y is equal to 19. Okay, so minus 2, when you plug it in there, you get 5. Minus 1, when you plug it in there, you get minus 5. Okay, and so forth and so on. Let's go through it and you finish that off and come back. Okay, so when we go through it, we fill the table. This is table of values. We have the corresponding y values for all the x values that we have chosen, and we need to graph that. Now, the simplest way to do this, you can do the freestyle, but we're going to go use Desmos. All right, and simple to do. One of the things that we like to do is with Desmos is that we are going to basically use this top value here, so that's where you're gonna go. All right, so I already created that already, but what you want to do, you want to come up here, you press the plus sign, and then you're going to go to table. When you click on the table, this will show up. The table shows up x, y without any numbers, and then you punch in the values in there, and then you just have to click in there and then punch in minus 3 and minus 2, minus 1, and then just write all of them down, and then equivalently you punch in 19, 5, minus 5, and all of those as well. Okay, so when you do all of this, notice that it plots it for you. You see that? The other thing that I did, I changed the grid scale. Notice that my x-axis is based on 1, 1, 2, 3. So each of these are 0.2 partitions, each of these boxes, each of these small squares for the x-axis. But for y-axis, each of these ones are 1. And I went up here with that wrench button there, I click on that and I change that manually for the x and y. Okay, so that's what I did. You can do the same thing. The reason I did that because I want you guys to see the pattern of the point. All right, and now you can actually do a freestyle and just really just go through it and then do the graph. Or what you can do is that obviously if you have a graph paper you can do that, but to check your answer, what you would do is you would come in and punch in the actual equation of the function 2x squared minus 4x minus 11, and then when you do that, look what happens. If you did these coordinates properly and accurately, it should go through the graph. Okay, here it is. Yes, it did. Fantastic. So that's how you create these the graph of a quadratic function using a table of values. Now, I do have to say it is not the most efficient way of doing this. In fact, it is quite cumbersome. I kind of knew where the bottom part of the graph is because that is the most important piece of that graph. There's a name for that. We're gonna talk about that later, but it is just the idea that if you have a set of data, for example, and especially if you're taking physics or chemistry, you do a lab, you have a set of data, and sure enough, you plot the points and you're going to generate a parabolic shape and you have to analyze it. You should be able to do that, and that's what the example is for. Okay, all right, now we're going to look at the second part of that question was the domain and range of the function. Okay, so the domain and the range. All right, now just a quick review. The domain, they were all set of x values that are possible for the function. Okay, so all x values. Okay, and what was the range? Range set of all y values that are possible for the function. Okay, excellent. Now, based on this table of values, you will not be able to know. You have to go to the graph. That's the only way you can do this, okay? So let's go to the graph again. Here's the graph we have. Okay, first of all, realize that the graph is parabolic, so the graph goes to the left and to the right forever. So if I actually zoom it down, and then notice that it just keeps going, going from to the left and to the right. All right, so all these values, it can go forever to the left side of the x value and to the right side of the x value, and that means that for the quadratic, the x is all set of all real numbers, set of all real numbers. That means that the way you write it, you will write it as d x belongs to set of all real number. Remember that this little symbol means belongs to, member of. Okay, and this r is the notation for the set of real numbers. That means basically everything works for all values of x. So all possible values of x, total real number system. Excellent. Now let's go back and see what happens to the y value. Y, or the range. Range is the y value, up and down, the y-axis. Notice that the graph has a floor. Okay, so this is the floor of the graph. And the floor of graph, I mean, if you click on that, you can notice that, by the way, that's one of the kind of features of the Desmos, where you can click on the point and it gives you the coordinate of it. Okay, so, and the coordinate, the y value here is -13. That means that this is as low as it can go. Okay, it does not go lower than -13, but it goes as high as infinity. Okay, so the way we have to write it is that, so with this parabola, it has a floor of -13 for y value. So the way you write it, you have to write it in a form, the range will be y. So I'm going to write it in a very systematic way. We say y such that, and in here you say y has to be greater than equals to -13, all right, comma, y has to be belonging to the all real number system. This is a very precise way of writing the range of the function. Okay, they're very precisely. And some teachers, some books, they insist that you actually learn that. We could have actually put that as well, just like that. That could be done as well. Why not? And then that would be the final answer for the domain and range. And the notation, you got used to it. So this little straight bar up and down, that means such that, again, mathematical language, notation, and that's what that is. Okay, so let's go back to the graph quickly one more time. There is a floor, -13. Y cannot go below -13, so everything above, that means greater than -13, is the range. All right, so that's what that is.